So let's begin by setting up our project first. So I have created an empty Unity project. It's a 2D project, and you should have similar scenes and all the folders. So first we'll create our gameplay scene and we'll save the scene. So we'll create a new scene and we are going to save our scene as the gameplay scene. And it will be saved up in our scenes folder. After that, we'll delete our sample scene. We don't need it. Let's change our build settings to Android. So currently, as you can see, it is uh, made to build for Windows. So we'll change our settings to Android. So all of the settings and the packages are aligned towards the Android build. And it will remove a couple of packages, so we won't need the testing ones, so that's why we'll use the Android. And we would also have the testing feature to include the Android phones and so it will take a bit of time. And after it has been switched to Android, we'll go inside player settings. And we don't need the text mesh pro, so we are not going to do that. uh, let's change the naming pattern to underscore and let's set up our packages. So there are so many packages. Most of the packages we are not going to need them, so we'll uninstall uh, all of them. So as you can see, the test framework, we are not going to need it. We are only going to need the Visual Studio Editor. And again, if you want to know that why this matters, because some of the packages maybe it will be using only 1 or 2 lines of code, maybe somewhere inside. But if you are not using it, then it will be added to the build, so it will reduce the build size. And what I have known is the visual scripting one, uh, it has the highest size, so I think it adds around 20 megabytes of build size, so we don't need them, so we are not going to use it. We'll directly uninstall it. And it will also speed up the builds and loading times. So removing it is going to take a couple of times. So that is going to be the setup for the packages. If we are going to use TextMesh Pro, then we would have installed from the project settings and disable the warnings and so. For the previous games, we may have done so. So the TextMesh Pro is already installed. Will not remove it, but the extra features. So timeline and UI, we are also not going to need the version control. We'll also remove the VS Code editor and the test framework. So let's remove the VS Code editor. And finally, we are going to remove the test framework. And TextMesh Pro, I think we should just directly install it as it is already included. I mean, it's a default package. Maybe you want to add some buttons and the background text is going to include some. So I just added it. And let's disable the warning. So in our any of the special characters are shown, it may show warnings and create some issues. So we'll update both of our packages and then we are good to go. And finally the timeline. Now what we are going to do is create our folders. So the first folder is going to be for our prefabs. The next folder is going to be for our resources. For now, the resources are only going to include the sprites, and the final folder is going to be for the scripts, which we are going to include all three of our scripts. So let's create those scripts. First one is going to be our game manager script, and yeah, I spelled it correctly. And after that, we are going to have our block and the background shell script. So let's create the C hash script for our block and finally our background cell. So again, the name I just forgot to add one more. So let's create the script again, and let's call it background cell. It has 12, and after that, we'll bring in our resources, which are going to be the tile sprites. And as I already done that before, I'm just directly going to copy it. So let's also include the meta files. So you can just directly copy from the folder and do it. And we don't need the prefabs, but we are going to need similar folder structure for our generator. So let's create our generator here, and we are going to create a new scene, and we'll save this scene as a level generator inside. I mean, let's just save it as a generator, and it is already saved. And here it is also going to have some prefabs and scripts. So what's prefabs we are going to need? We'll see that afterwards, but let's first see what scripts are we going to need. So the first script is going to be similar to our game manager. Here we are going to call it as level creator. And the second script is going to be similar to our background cell. Here we'll just directly call it as cell. And finally, we are going to create our block. And here it is called the spawn block. So these are the scripts we are going to need for our generator. Prefabs will need to create. In the next part, we'll uh, I think there is one more script inside our main, which is going to be a scriptable object, and I'll call it level. So these are all the scripts needed, and the folder structure will be similar. You won't have anything extra except for the prefabs, and that's it for the setup. In the next part, we'll start by creating the grid, and let's add to the build. So let's go to the next part. So in the previous part, we created all of our scripts and added all the resources, and now we'll first create our scriptable object, which is going to store the level. So let's do that, and then we'll create all of the prefabs, and we'll see what we'll need to do. So the first, let's go inside Visual Studio, and this is our level. So right now it is inheriting from the mono behavior. We need to inherit from the scriptable object, and we also need it to like create a menu for it. So we'll use create asset menu, and for our first format we'll set our file name to be equal to level, and let's use a comma, and our menu name is also going to be equal to level. So we can just directly right click and there'll be an option for menu uh, named level, and when we hit it, it is going to create a level. It is going to be similar like how we create materials, but we would have the option for creating a level. And here we are going to have a public integer for the rows, public integer for the columns, and public list of integer for our data. And then we are going to have a public integer for the block rows and a public integer for the block columns, and public list of blocks, which we are going to create as a separate struct. So we'll call it block piece. And yeah, so it is not going to need that. And it's going to have a public vector to int, which is our starting position. So the row and the column index. and public vector to int, then it is going to be a center position and it is going to be from the original board. Then we will also have a public integer for the id. So what color is it, we want to know, because there may be duplicate blocks and we need to remove it. And finally it is going to need a public list of vector to int, which is going to be our block position. So if it is a single block, then it's there's no problem. But if it is a group of blocks, then we need to know their arrangements by row and the column. So that's why we are going to need it. And this list of blocks are going to be saved inside our level. So it needs to know what blocks are there, and this needs to be serializable, so we'll use the serializable attribute, and after that our level is going to be created. So this is the structure for level, and what we'll do is create this level inside our prefab. So let's create level, and as you can see, it created our level. The default name was level. The rows and columns are going to be 3 cross 3, and 3 cross 3 is going to include 9 size 9 data, and everything by default it is going to be 0. uh, uh, as of in our editor, it is going to have different values, where -1 corresponds to if it is a block position. 0 is for empty, most likely nothing will be empty, but it is denoted for empty. And the block rows are going to be 3 cross 3. Let's have it similar, and we are going to have just 3 blocks. Let's set its ID to 0, and the block positions are going to be 0 0, and the row is going to be increased, so -1 and +1. So it will be like a vertical block, and after that we'll duplicate those blocks, so we just need similar blocks. And the id is going to be 0 here, the id is going to be 1, and the final one. So the structure is similar for all three of the blocks, just the start position is going to be different, so where it is going to be arranged. So let's put the first one at the center, which is the 1 1. Now we are going to just move one column to the left. So the row is going to be 1 and column is going to be 0. And for the next one, the row is going to be 1 and column is going to be 2. We will not need the center position, so it is for the editor. And I already created the whole game before, so that was needed. And we don't have to go and come and check back here. So that's why it was created. Now let's create an empty, and this is going to be for our game manager, and we'll attach the game manager. So uh, that's how simple our scene is going to be. Everything is going to be attached as prefabs and manage the scripts. Now let's create our rest of the prefabs. So what prefabs are we going to need? So the first one is going to be our background cell prefab, which just similar sprite renderer, and it is going to have the background cell script and nothing else. The sprite we are going to use is going to be, let's add the black one, and everything is 128 by 128, so the settings are also copied. So the size of the whole block is going to be 1, which is going to be your default size, and its ordering layer is going to be -10, which is going to be the most backs. It will be at the back. And after that we are going to have the block cell. Let's create our first, which is going to be our block. So blocks is just going to have our block script and nothing else, and we are going to save that as a prefab. Let's delete it, but we'll need to create our block cell. Yeah, we'll call it block cell, and it is going to have a sprite renderer, which is again going to have the tile, or let's add a blue tile. Its ordering layer is going to be higher, so we'll have it at 0. Yeah, we'll have it at 0. And after that, it is also going to need a box collider 2D, which is going to be a trigger. So we need to detect, and all of them are going to be spawned inside the block depending on the row on the column. So let's save that. And these are going to be your prefabs. And in the next part, we'll see how we are going to use this prefab. So let's change up to a simulator view. And let's use iPad 7 Gen. Anything better? Yeah, iPad Pro 12.9. This one looks better. And let's change our main camera's color to white. So no other changes there. We just added all three of our prefabs, and that's mm, most of the part is going to be in the scripting. So we'll start in the next part, and let's go to the next part. Let's set up our grids. So for spawning the grids, we are going to pass the value from our level. So it includes the number of rows and the columns, and also the data, which is by default here it is going to be 0. So that means it is going to be filled, and there are going to be a couple of variables. So let's see what we need to do. So let's go inside Visual Studio, and what we are going to call now is our background cell. So our background cell is going to need our let's create a hidden inspector, and it is going to be for a public boolean of is block, and also a hidden inspector public boolean of is filled. So whenever it is filled, we are going to change its color to highlighted, and the block is always going to be set up at start when the value is going to be -1. So let's get a sprite renderer, and we'll call this background sprite, and serialize field private sprite for our empty sprite. So whenever it is empty, it is going to be gray colored, and whenever it is not empty, it is going to be block sprite, which is going to be our black. And then we are going to have color for the start color, then color for our correct color, and the incorrect color. So at the start, if it is not blocked, then both of them are going to be white, but we'll need to change the colors when we highlight something and the block position is wrong, so it is going to be changed to red. And unity dot, we don't need it. And after that, let's create our end function, and here we are going to pass the value, and is block is going to be our block value is equals to -1. If it is not -1, that means it's not going to block. Then if our is block, then our is filled is going to be true. So it is always going to be filled. So whenever you want to detect for any winning conditions, then it will just return true. And we'll set our background sprite dot sprite to be equal to if it is blocked, then we'll set it to our block sprite, as it is going to be our empty sprite, and nothing else. And also we are going to need public void reset highlight. So whenever our highlight is resetted, our background sprite's color is going to be set to our start color, and public void update highlight. Here we are going to pass a boolean, which is going to pass the value if it is correct or not, and We'll check if it is correct. So background sprite dot color is going to be is correct, and the value is going to be correct color, else it is going to be set to the incorrect color. So pretty simple script, just the initialization and resetting the color and setting if it is true or false. We will use it later inside our game manager. So both of the scripts are done, and now we'll go inside our game manager. So for the game manager, we'll just create all the variables, and then we'll create the functions. So let's see, what variables are we going to need. There are not many. So the first one is going to be our public static game manager instance, and inside our awake we'll set the instance to this. Maybe we will need it, maybe we won't, but who knows. Let's create a serialized field for our level, and we'll call this level. Then we are going to have a serialized field for our private background cell. We need to access that, and we'll call this background cell prefab. Mm, and after that, we are going to have a serialized private, and this is going to be our block, and we'll call this block prefab. This is going to be for our block piece, serialized field, private float, and block font size. And after that, we are going to have a serialized field, private float, block, highlight size. So whenever we are going to highlight, then it is going to be not perfectly sized one. It will be around 0.9 or whatever you like. So next we are going to have the block. uh, there's naming low light size, put size. So whenever we put it down, it is going to be changed to size 1, and that we are going to save through a serialized field. And then we are going to have a 2D array of our background cells, and we'll just call it background cell grid. And after that, private bool for has game finished, and private block for our current block. So what block are we clicking? We are also going to save it, private vector 2 for our current position, and the previous position. So whenever we are dragging, we'll drag it by the offset, and then our list of blocks, and we'll just call it grid blocks, which so these blocks are just the blocks which are on the grid. There will be some blocks which will be not some, I mean most of the blocks will be at the spawn, but whenever we put them in the grid, we are going to store it inside our list, cause we need to update all of our background cells. So wherever those blocks are placed, we'll get the positions, and we'll update those values to true. And if all of them are filled, then the game is going to be finished. Now let's see what we are going to need inside our awake function. So as game finished is going to be false, and after that our grid blocks are going to be new list of blocks, and we'll spawn the grid. And after we have spawned the grid, we are going to spawn our blocks. So let's create our spawn grid function, and also our spawn blocks function. So our grid is positioned at the corner of 0, and the center position will be at 0.5 and 0.5, each of them distanced by the cell size for our grid, which is 1. So let's set up our background cell grid, and it is going to be a new background cell grid, and it needs to be a 2D array, and we are going to pass the row and the column via so the saving will not use by the xy coordinate, will go by the row and the column. When we convert it to transform, then only we are going to use it as the x and the y coordinates. So the rows and the columns will be interchanged. So suppose it is at the first row and the second column, then the position will be 2 and 1. because the first row has the y coordinate of 1 and the second column has the x coordinate of. So just remember that the row comma column is equals to y comma x, not x comma y. Just pretty simple. But the position will only use when the transform is involved, else we are not going to use it. So let's use the level dot rows, and after that we are going to go for our level dot columns. And we just need to spawn our background cell, so let's call it background cell is going to be instantiate our background cell prefab. And after instantiating, we'll set the transform position to be a new vector 3. And for the x coordinate, we are going to pass our j value. As I told, the positions are reversed. Similarly, for the y coordinate, we are going to pass the I value, and for the z, it is going to be 0. And we will initialize with our data, which is level dot data, and the position we need to pass is I. And remember, I denotes a row, and the size of the row is the number of columns it has. So I multiplied by uh, columns. Yeah, I made a mistake in the previous part, and plus j. So it is going to return the position. So j is going to return the column, and the number of, yeah, the size of I is going to be level dot columns, and it is going to initialize it, and we'll also set the background cell grid of I and j, which is going to be our background cell to be equal to our background cell. So whenever we want to access the background cell, we can directly get it from the grid. And let's see what we need to do. So that's it for the spawning code, and we are not going to change the camera and such. So what is going to be needed for our game manager? So let's attach the block, the background cell, and also the level. And the block spawn size is going to be 0.5, highlight is going to be 0.95, or maybe around 0.8, and the put size is going to be 1. And let's go inside our block cell. It doesn't have, yeah, the block, it doesn't have any script. The background is going to be needed, so let's attach the background sprite. We will also need to empty and the correct sprite. So empty is going to be a gray, and block is going to be a black. The start color is going to be white, and the correct color is going to be uh, green. So let's add the greenish color, and the incorrect color is going to be red. Let's hit play, and what we should see is a grid of blocks. As you can see, the blocks are spawned correctly, not there are not any issues, and that is going to be forward spawning our grid. So in the next part, what we'll do is we already spawned our grid. Now what we need to do is spawn our blocks, but they are going to be spawned inside our spawn row, which is going to have a different starting position and different size. So let's see how we'll do that. So let's go to the next part. So we created the background cells, and we also completed its script. So when we want to use it for resetting the highlight or updating the highlight, then we can use it, and we spawned it. And after that, what we need to do now is spawn all of our blocks. So it is stored as a list of block piece, so it is a different structure where we are going to have the starting position and its configuration. So let's finish that up. And let's go inside Visual Studio. So you should be see the Visual Studio, and we'll create the script first, and let's create a serialized field, and it is going to be a private sprite renderer uh, for our block prefab. and serialized field private list of sprite for our block sprites. Serialized field private floor for our block spawn size. And so the default spawn size, I think it will be at 1. Yeah, transform.local scale. So, yeah, it will be set at 1. So we are just going to change the transform dot local scale. So its scale is going to be 0.5. So, and after that, we are going to have a private vector 3 for our starting position, private vector 3 for storing our previous position. So whenever we want to reset, we are going to reset to the previous position, and private vector 3 for our current position. So our current position will get updated more, and private list of sprite renderer, and it is going to be for our block sprites. As we are going to move it around, we need to change its order in layer, and private list of vector 2 end, and this is going to be for our block positions. Correct, detected it. So we'll need the block positions, and when we add the current position, we are going to get all the filled positions. So the block positions are relative to the center, and whenever we add the current position, then it will be relative to the grid, and we'll just mark all of those grids to be filled, and that's how we are going to set it. Next, we are going to need an initializer function. So what values are we are going to pass in the initializer? So we are first we are going to need the list of vector 2 end for the block positions. So we'll just call it blocks. Then we are going to need the start, so wherever the starting grid is, and an integer for the block number, which we are going to pass as the id. Let's see, first we'll set the start pose to be equal to start, and our previous pose is going to be equal to start, and also our current pose is also going to be equal to start. Our block positions are going to be equal to blocks, and our block sprites are going to be a new list of sprite render. Now we need to spawn all of our blocks block positions dot count. So we are going to spawn for each of the block positions. So let's create a sprite renderer. Spawn block is going to be equal to instantiate, and we are going to instantiate our block prefab at our current transform as parent. Not this, pass the transform, then spawn block dot sprite is going to be add block sprites of block number plus 1, because there's going to be a minus 1, and yeah, so there is going to be a minus 1. We can rearrange it, but we are not going to do, we'll need to do something else. So, and we need to set the spawn block dot transform dot local position is going to be the new vector 3, and for the x position we are going to pass the block positions of I dot y. So the y belongs to the column, and the column denotes x position, x and 0, and we are going to add it to the block sprites. So block sprites dot add our spawn block, and we'll elevate all of the sprites. So elevate sprites, and we'll pass the true. So here true is for if you want to reverse it, elevate sprites. Yeah. And let's create our elevate sprite function. Elevate sprites bool reverse, and by default is going to be false. So whenever we call the elevate sprites, for each sprite inside our block sprites, block sprite dot sorting order is going to be, if it is reverse, then it is going to be bottom, as it is going to be top. So if we pass so if the reverse is going to be true, then it is going to be pushed at the bottom, which is going to happen at start. And whenever you click it, we'll just call the elevate sprite functions with no values. So by default, it will be false and it will be elevated. And let's now create the rest of the functions. So the first one is going to be our update position, and here we are going to pass the offset. And what we'll do is we'll add the offset, and we'll set the current position. I did it reverse. So our current position plus is going to be offset, and our transform dot position is going to be our current position. So our position is going to be updated, and it will be saved to the current position. Now let's create a public list of vector2 integer to get our block positions. So again, it's going to be simple. Let's create a public list of vector2 and for our result, and let's add it as a new result, and let's use for each position in block positions, we are going to add result dot add position and new vector3 vector2 int, and let's see what the first value we are going to pass. So the first value is going to be mathf dot floor to int, and it is going to be our current position dot y, and the next one is going to be mathf dot floor to end current position dot x. So it is going to return the row and the column, so that's why the x and the y are going to be interchanged. And where is the error? Yeah, we'll need to return the result. So the result is returned, and this is going to be for the block positions, and also public void update incorrect move. And whenever we are going to have the incorrect move, then we'll set the current position to be the previous position, and our transform dot position is going to be the current position. Then next is going to be the update start move. So if we moved it outside the grid, then our current position is going to be the start position, previous position is also going to be the start position, and our transform dot position is also going to be our current position. And finally, when we update our correct move, so our current position dot x is going to be mathf dot flow to int of current position dot x, but we need to add 0.5 because that's the center. Similarly, we'll set the y to be mathf dot flow to int of 0.y. So we'll just directly set, and our previous position will be set to our current position, and our transform dot position will be equal to our current position. So these are all the functions that we are going to need. So updating the position whenever you want to change its position, uh, pushing all the sprites to the front, getting all the positions with respect to the grid. So by default, they are respect to the center. Updating the incorrect move, updating to the start, and updating the correct mouse, so it will be positioned at its wherever the closest center is, and the initializer. And now let's go inside Unity, and what we'll do is attach all the values for our block. That's the only script that we are going to need. And we'll also need to attach the values for our game manager. Yeah. I think, yeah, the game manager is finished. So the block spawn size at start is going to be 0.5. The block prefab, we have already created the block prefab, but it is going to be a block cell prefab. And we are going to include all of our, let's log the inspector, all of our sprites. So let's first include our first sprite, which is going to be our black, and then our next sprite, which is going to be our gray. The gray is not going to be used, but that's how the ordering is. So -1 denotes for the black, 0 is for gray, and the rest are the different IDs. And after we have done all of that, let's go inside the game manager and let's see how we are going to spawn all of the blocks. So we are going to need the starting position, and we are also going to update the camera position. So let's first get our starting position to be set to 0. Then we'll set the start pose.x to be equal to 0.25, which is going to be the left corner, and columns minus level dot block columns. So how many columns there are, that many amount multiplied by the block spawn size, and finally we'll multiply it by 0.5. So let's suppose the level dot columns multiplied by 0.5, so it is going to denote the center for our first grid. Then our second grid is going to have a different center, and um, the center for our second grid is also going to same, but the leftmost position will be depend on the block columns, and we also need to multiply it by the block spawn size, and finally everything is going to be multiplied by 0.5, and this will be the leftmost corner. And if we add 0.25, we are going to get the start position for our left 0 cell. And similarly, the y position is going to be negative level dot block rows. So negative level dot block rows, and we'll multiply it by 0.5, and we'll add 0.25, and we'll also subtract 1. So the y coordinate is there, and I don't think we'll need to multiply it by 0.5, but mm, mm, mm. Maximum rows, maximum columns. Okay, okay, okay. So as many rows are there, block rows. Yeah. So this 0.5, that is for our block spawn size. I thought it was like just putting it to the center. So it is always good to, like, instead of putting numbers, save it as a variable so you know what we are going to do. We'll just leave the 0.25 here, that is for the offset for the grid, and 1f is going to be for the gap between the two grids. So now we have both the starting positions. So what we'll do, for int I is equals to 0, I less than level dot blocks, So level dot blocks dot count. We are going to spawn each of the block, and let's first spawn the block. So it is going to be a instantiate, and we are going to instantiate our block prefab, and vector int block position is going to be equal to level dot blocks of I dot starting position, and vector 3 block spawn pose. We need to change it here, so that's why I converted it there. It's going to be a new vector 3. System dot numerics, don't include it here. Collections, maybe background cell level block collections not needed here. So new vector 3, we have the block position, but remember they are the rows and the columns. So the x coordinate is going to be the y coordinate, which is the column and the row. So block pose dot x and 0. So this is going to be starting position. Then we'll need to initialize it. Block dot transform dot position is going to be the block spawn position, and block dot init, and we are going to pass the level dot blocks of I and dot block positions and block spawn position, and finally level dot blocks of I dot id. So this should spawn us the block, and it is going to initialize it from the script there which we have created. Now let's set up our camera. So the maximum number of columns are going to be mathf.max, and it is going to be level.columns and level.block columns multiplied by block spawn size, and float maximum rows is going to be similar to mathf.max of max columns and max rows multiplied by 0.65. So it just not. So this is going to be the column size, which one is higher. So float maximum rows, and it is going to be level dot rows plus 2f plus level dot block rows multiplied by the block spawn size. So the rows and the columns denote the x coordinate, and the rows are going to be the y size. And we can set the camera dot main dot orthographic size is going to be mathf.max of max columns and max rows, and we'll multiply it by 0.65. And after that, let's get our camera position, which is camera dot main dot transform dot position. Campos dot x is going to be directly level dot columns multiplied by 0.5, and the y coordinate campos dot y is going to be equal to, so the top is going to be at level dot rows, then we are going to add 0.5, and then we'll add the start position dot y, and finally we'll multiply all of them by 0.5, so we'll get the center box, and this should position the camera at the center. So this one is a little bit large. And finally we'll set up the position. So camera dot main dot transform dot position should be equal to campos, and now everything should be done. And we should be able to go inside Visual Studio, and suppose there were not any errors, we should see three blocks spawn here. But the issue is, yeah, so they are spawned maybe correctly, maybe incorrectly. The issue is just with the size, which we forgot to change. So where did we forget to change? Maybe inside the start. Yeah, transform dot local scale is going to be 1 multiplied by the block spawn size. Now let's see how it arranges. So it is again at 3 cross 3, and now it should not again, again, again. So there is an issue with the spawn position again, again, again. Hmm, hmm, hmm. So let's go inside Visual Studio and so where is the problem? Okay, local position. We just pass the y and the x. That is not the problem. That is completely correct. But here it should be inside our game manager where we set the position. We need to multiply it by our block spawn size. So let's add the block spawn size. So that was a problem. And let's see now what happens. The spawn position should be correct. That's why it is good to test the code. And I just do it bit by bit. And as you can see, the center one is gray color because the ID for 0 is gray. And let's see which one it is. Would be the start one. And let's set its ID to somewhat free. Now it should be fixed. And what was that? We need to multiply it by the block font size because the grid size was different. And for the previous one, we also forgot to change the scale, which was I forgot to copy, and that's how our blocks are going to be spawned at the start. And the code is not dependent on like the grid, the starting position, so we didn't directly measure it and position it randomly. We calculated everything, and everything is with respect to the starting position, which is respect to the original grid, and all the spawn blocks are with respect to its center. And we cannot directly code all the complex blocks as we did it here, but what we can do is create a level editor and edit the level from there, and all of those data is going to be stored inside our level. So after creating our main gameplay loop, we are also going to do that. So let's go to the next part where we are going to update our movements. And again, this lecture was pretty long. So in the previous part, we spawned our blocks. Now we also need to move our blocks, and most of the code logic is going to be inside our game manager. Whatever the functions we need to call, we already added to our block, and we just need to detect the clicks, move it around, highlight it, and finally position it correctly if it is at a valid position. And if it is below the center line, then we are going to put it at the start position. And if it is at the incorrect position, then we'll put it at the previous position. So pretty simple, and we are going to do it inside our game manager. And the block script also, where is the block? So that is the update position script. We need to elevate the sprites, and also everything is almost created. The variables are also there. Now let's go to the update function. So the first thing we are going to check if our game has finished, and we are going to return. And when our game is going to finish, so we need to create that function, and it is going to be a pretty simple function. And we'll call this function as check when private void check when. And what we'll do is for int I is equals to 0, I less than level dot rows for int j is equals to 0, j less than level dot columns. If not, background cell grid of ij dot is filled. So if nothing is filled, then we are going to return. But if everything is filled, then the game is going to be finished. And first we'll set the has game finished to true. Then we are going to call the coroutine game over or game win, and we'll create the coroutine, which is going to be a private enumerator. And what it is going to do is we'll just wait for 2 seconds, and after that it is going to restart the scene. So that's just one scene. So we'll just unity engine dot scene management dot scene manager dot load scene, and that's just one scene. So we are going to pass the 0 as the index. So when the game finishes, we don't need to move anything. And mm, similarly, um, let's just create our helper functions as they are going to be pretty simple. So is valid position, and we'll pass our vector2 int of our position, and what it should return is return pos.x should be greater than equal to 0, and pos.y should be greater than equal to 0, and pos.x, so x is going to be for the rows, and we are just directly passing the rows, so we'll just use that. And pos.y should be equal to level.columns, and private bool for its correct move. So whenever a move is going to be correct, so when the current block, so for each position inside our current block dot block positions, did we rename it block? Yeah, let's rename it to block positions, because I think we have block positions here. So for each of the block positions, if is not is valid grid or is valid position, or our background cell grid for our position dot x and position dot y. So we can just directly pass the x and y because both of them are similar. It's filled. So if it is not filled, then it is not going to be a correct move. So it is an incorrect move, and will return false. Else, if every position passes, then we are going to return true. And also, let's create our private void update highlight, and if is correct move, then we are going to update for each where pause in our current block positions. We are going to update the background cell grid for the pose.x and pose.y to be update highlight, and we'll pass the true because the value is true. But if it is not the correct move, that means it is an incorrect move. Then for each position, I mean, we can just yeah, let's just do that. So I just no. So we will be calculating the value again and again, so that may be an issue. Hmm, 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 hmm. Pool is correct, is going to be is correct move, and let's paste. So if let's paste it here, and if is valid pose, then we are going to set this value to this. Okay, so previously it was like a little bit messy code, and what I did was just cached it, and instead of using an loop, I just passed the value. So the code looks a bit simpler now. And after updating the highlight, we need to reset the highlight. So private void reset highlight, and for resetting, what we are going to do is we will go through all of the background cell grid level dot columns, and if our background cell grid of I comma j is blocked, if it is not blocked, then we are just going to set its filled value to be false. So by default, everything is not going to be filled. So reset highlight, yeah. So this is just going to be for resetting the highlight. In the next function, we are going to set it to false and then set all the correct values to true. Let's copy this loop again, paste it here, and if it is not blocked, then we are going to set our is filled to be false. So at first it is going to be false, and after that, for each of the block values, it is going to be true. So for each block inside our grid blocks, and for each position inside our block positions, we are going to set the value to be true. So we have the positions, and if it is valid, then we'll set it to true. So if is valid position of our position, then it's always going to be valid, but maybe somewhere I was getting an error, so that's why I'm adding an extra check here. Position.x and position.y, and we'll set the isFilled value to be true. So let's see what functions we created. So checking the win condition, pretty simple, everything should be filled, and blocked are not going to change, they are always going to be filled. The correct move is going to be for our current block, every position should so if it is filled, then it is going to return. So if it is not valid and if it is filled, then it is going to return false. But if everything is going to be unfilled, then it is going to return true. So that is for our correct move. Finally, for updating the highlight, we'll just pass the value if it is correct or not and pass it to the positions. Updating the field is also pretty simple. We'll just reset everything, and whichever blocks are placed, we are going to set the field to true. Resetting is just calling the function again. And now let's see what we are going to do inside our update. So the first detection is going to be whenever we click our mouse. So camera.main dot screen to world point of input dot mouse position, and we'll convert into a vector 2. So mouse pose 2d is going to be new vector 2 of mouse pose dot x and mouse pose dot y. And if input dot get mouse button down of 0, then we'll do a raycast it 2d. we'll call it hit. It is going to be physics 2D dot raycast, and it is going to be for the mouse position and in the 0 direction. And if not hit, then we are going to return. But if we have hit, then we'll set the current block to be hit dot collider dot transform dot parent dot get component, and we are going to get the component block. And if our current block is equals to null, then we'll return. So so our current block was null, so that's why we are going to return our current position is going to be our mouse position 2D. Mm, mm, mm. Mouse pose 2D, and also our previous position is going to be mouse pose 2D. Current block dot elevate sprites. Maybe I created as a private. It needs to be public. So it is going to be elevated to the top, and our scale is also going to be needed to change. So current dot transform dot local scale is going to be 1 multiplied by our highlight size. So block highlight size, and if our grid blocks dot contains our current block, then we are going to remove it. So reference are going to be same, so we can just directly add it. Then we'll update the field, and after updating the field, we are going to reset the highlight, and then we'll update the highlight, and we can reset the field, so everything is going to be turned white. Then everything is going to be filled. Finally updating the highlight. So does highlight call update highlight, yeah. So depending on if it is correct or not, it is going to call it. So that is going to be the correct order. Reset it, then fill it, and finally update it. Now similarly, if we are just dragging it around, so else if input dot get mouse button down of 0, and our current block is not equal to null, then we are going to input dot get mouse button of 0, or else it will not work. So our current position is going to be equal to mouse position, and then we'll update the position, and we'll pass the offset, which is should be current position minus previous position, and our previous position is going to be equal to our current position, and we need to reset the highlight, and then update the highlight, update the field. Updating field is just going to be needed once. We need to just update the highlight. Update field, update field, update field. So update field is just for the starting blocks, and we just turned it off, turned it all on, just reset it and update it. And finally, if we release it, so else if input dot get mouse button up of 0, and our current block is not equal to null, then let's use a reset highlight, update the field, and check the win. And before that, we need to set the current block to be equal to null, so it does not create problems. So let's elevate sprites to true. So the reverse value is going to be passed, so it is going to be set to the starting position. And let's add the condition. So the first one is going to be if we are the what if we are the so if at the end we have positioned our block at a correct position, so that's why is correct move is going to be true. So if it is going to be correct move, current block dot update correct move, we don't need to pass anything. And current block dot transform dot local scale is going to be 1 multiplied by foot size. And finally we need to add it to our grid blocks because it is correct and it is positioned at the grid. Else if mouse force 2d dot y is less than 0, that means it is below, then we'll just directly position at the start. And we will set current block transform dot local scale is going to be 1 multiplied by block spawn size. Else that means the move is incorrect and it is greater than 0. Then hmm, hmm, hmm. So move is incorrect and it is greater than 0. So current block dot update incorrect move, then it is going to be there. I mean, it is going to be added. We need to, yeah. So it is going to be added to the grid or to the starting position, but we need to check if it is added to the grid. So current block dot current pose dot y. So where is our current pose? So it should have been updated. Yeah. And we need to get it. So I think I forgot to add that. So it is going to be a public vector 3. Let add v1 to it. We don't need that. Public vector 3, and it is going to be our current position. And what it's going to return is new vector 3 of current pose dot x, current pose dot y, and 0. I mean, we could have added a boolean, but doesn't matter. Current block dot current pose dot y is greater than 0. That means it is positioned at the grid instead of the start. Then we need to add it to the block. So we'll do current. We update the incorrect move. Grid blocks dot add. Grid blocks dot add our current block, and our current block dot transform dot local scale is going to be 1 multiplied by foot size. Else that means it would be at 0. Then current block dot transform dot local scale is going to be at 1 multiplied by our small size. So if it is incorrect, then there are two positions where it could go, and that should be done. So I don't think there are any problems, and we should be able to play the game. And again, this was pretty large, around 20 minutes, but doesn't matter. So let's hit play and let's break our game first. So we can move it around. It is showing the correct, so the game didn't break. And if we position everything correctly, then we should be able to see the game finished, and we cannot click anywhere and the game is finished. And it worked perfectly fine. So almost all the functions were correct. Instead of creating the code, we just created functions one by one and understood what it meant, and finally added those functions, check the conditions. So as you can see, it is the code is almost pretty simple. There is nothing complicated. The only variables we are passing here is our mouse position, which we can directly get as a different function. uh, we could have created another function where we can understand what it's doing, but It's almost 200 lines of code, and you can understand it by going it through once. So that was it for the gameplay, and in the next part we'll start creating our editor. So let's play the game again, and let's see if it is checking all the conditions. So it directly detected. So here again, we can place it anywhere. If we place at the incorrect move, then it is going to be restarted at the start. And again, incorrect move, place it here. We cannot place it here. And that's how simple it is. And in the next part, we'll start creating the level editor. So let's go to the next part. So in the previous part, we finished our gameplay scene. Now we need to create, we already created one more scene in which we need to add it to our level. And we are going to do it in the play mode. I could have created in the editor, but it gets pretty much complicated and the coding would not be similar. And to just save it, we just need to use editor utility dot save whatever the scriptable object is, and it is directly going to save the changes. So not much difference is there, and the code will be pretty much similar as we like play the game, and the data will be saved. So we have our gameplay scene. Now we are going to change to a generative scene, and we don't need the simulator. We'll use the prefab. Let's set the color to white. Let's create an empty for our level editor. So in this part, we'll just create all of the prefabs, so we don't need to use them again. And we'll set the initializer to all of the prefabs. So there are a couple of scripts for the spawn block and the cell. So we are going to initialize it. Let's add the level creator script here. Let's see what prefabs we need to create. So the first prefab is going to be our block prefab. So it is the simple block that we are going to use for our cell. So let's add the block, and add a sprite renderer. So it is at the top. The sprite we are going to use is sprite black, and the ordering layer is going to be 2. And we are going to save it as a prefab. Let's delete the block. And then we are going to have a block piece, and our block piece is going to have the spawn block script, and the scale is going to be 0.5. So we are just directly setting up the scale here, so it just corresponds to our block, but here we called it block piece, and the block is the block cell. So just remember that block is the block, and the block piece is the whole piece. And then we are going to create the cell, which is our default cell. Let's add a sprite renderer, and ordering layer is going to be 0. Let's attach the sprite to be sprite black, and it is going to have the cell script. And we'll edit the script and add it again, and by default it is going to be gray. Let's no need to add the black. And also in this prefab, most of the blocks are going to be bluish colored. So let's also say our cell as a prefab. So this is going to be our background cell, and then we are going to need a center, and our center is going to be size 0.5. It is going to have a sprite renderer, which is going to have the color of black. And we'll duplicate the center, parent it again, and set the size to 0.75. Add the blue and set the ordering layer to 1. And we can have the different ordering layers, so 1 and 2, so it is above all of our cells. And we'll also save this as a prefab. So let's go inside our prefabs, and we are going to save our center. And finally, we are going to have our spawn block. So this is going to be similar to the cell, but the only difference is going to be, let's add, so this one is going to be gray. The size, it's going to be 0.5, but let's delete this and we'll create an empty and we'll call this spawn block. And it is going to have sprite render attached. The scale is going to be 0.5, and for the prefab and the resources, let's add the tile black. Ordering layer is going to be 0, nothing changed, and we'll save this as a prefab. So we created all the prefabs, and now what we need to do is let's initialize our cell and the block piece prefab. Both of them are pretty easy, nothing too complicated. So let's go inside our level editor or the level creator, whatever I call it as, and we'll open up all three of our scripts, and we'll start with the cell script, as is going to be the simplest. So our cell is going to have a public integer of cell value. We'll need to get and serialize field. I need to change my keyboard sometime soon. Private list of sprite, and these are going to be the cell sprites. So what color it's going to be, and serialize field private sprite renderer, and we'll just call it cell renderer. Private int for the sprite index, and it is going to be cell value plus 1, and let's create our initialization function. So public void init, will pass the int cell value, and we'll set the cell value to be equal to cell value, and we'll set the cell renderer dot sprite is going to be well, sprites of sprite index, pretty simple, nothing too complicated. And whenever you want to change, we'll just call the init function with the desired value. Similarly, let's go inside the spawn block. Let's create a serialized field, private transform, and we are going to have the block prefab and serialized field, private list of sprite, and let's call this block sprites, and serialize field private float for our block size, and finally public void init, and we are going to pass our block piece and also the grid start. And let's first set our scale to be equal to 1 multiplied by block size, and after that our position to be equal to grid start, and then we need to pass a new vector 3, then piece dot start pose dot y, so, and we'll multiply it by the block size, and finally block size and 0. So it is going to set up the position, and let's get the current sprite equal to sprites block sprites of piece.id, and we'll add 1. So it is going to return the sprite, and for int I is equals to 0, I less than piece.block positions.count. Let's create our first block, and it's going to be instantiate, and we are going to instantiate our block prefab at transform block prefab a transform, and after that we'll set its position. Let's add a new vector 3, and for the x position we'll pass piece dot block positions of I dot y column, and finally dot x and 0, and block dot transform dot local position, not actual position, and finally block dot get component, and we are going to get the sprite render component, and we'll set the sprite to be equal to the current sprite. So these are just the two initialization functions we are going to need, and we could have created in the next part, but they are pretty simple, so I just created at the start, and we all the prefabs and the final changes. Everything else is going to be inside our level creator. So what else is not going to need it? Generic. Mm, maybe we'll see it in the next part. So we just set up the prefabs and create the initialization functions. So for the cell, we just need to set its color and update the cell value. And for a spawn block, we need to set its scale, which should be 0.5, and set its position, which should be dependent on the start position, and set its sprite and spawn each of them, and each of the blocks, and set its position and sprite. So we'll spawn our grids and everything else in the next part, and let's go to the next part. So in the previous part, we almost created all the prefabs, but I forgot to add one more, which are going to be the buttons we'll need to add. So let's create an image, and we'll delete this image first, and let's set up our canvas. So instead of overlay, it is going to be camera. Scale with screen size, we'll set the X to be 2160 by 1080. And first, we'll create an empty, and this is going to be our button holder, and our button holder is going to have anchor of left center, position is going to be 80, and the size is going to be 160 by 1024, and we can see it inside our WT. So this is our button holder. We'll add a vertical layout group, and let's fit the spacing to 16, alignment to middle center, and we'll add a couple of images. Let's set our first image, which is going to be button under slash 0. The sprite we are going to use is the black sprite, and let's change its size to 80 cross 80. So that is aligned correct, and we'll add a button component, and we'll duplicate the sprite multiple times, and we are going to have almost 8 sprites. And the second one is going to have the grayish color, the third one is going to have the bluish color, fourth one green, fifth one orange, pink, red, and yellow. So these are going to be our editor sprites. Whenever you click them, it is going to set the current value, and instead of 6, let's make it 8. We don't need to expand height, let's set it at 60. And yeah, into 1.5 minutes. Now what we need to do is spawn all our blocks and all our grids, which should be at the center, all our spawn grids with the blocks with its center position wherever the center is. So we'll need to do that, and everything else is going to be inside the code. So we just switch to code, and it's going to be almost pretty big code. So Let's spawn everything and we'll create the variables. So the first variable we are going to create is level creator instance, and inside our awake we'll set the instance to this. Maybe we'll need it, maybe we'll not. Let's create a serialized field, caps lock private int, and this is for the rows, columns, and this one is for the spawn rows and spawn columns. And we are going to have a private transform. This is going to be our spawn background prefab. So wherever everything is spawning, we are going to have some background so it doesn't look empty and we can know where our center is. Serialized field private level. So the level which we need to get the data or update level. Then serialized field private cell for our cell prefab, where we are going to update changes. Serialized field private float private transform, and this is going to be our center prefab. And serialized field private float for our block spawn size. By default it is going to be at 0.5, but if we need to change it, we'll change it from there. And we are going to have a private list of sprite for our block sprites, and these are going to be all the black not yeah, we can just directly call them block sprites. And serialized field private, and this is going to be our spawn block where we need to update its position, so we'll call this block prefab. Let's go to the private variables. So private bool is new level, and private cell, it is going to be 2D array, and we can just directly call them as grid cells. Private int for our current cell fill value. What value is going to be filled? Private dictionary, which goes from integer to vector2 int for our starting positions. So we'll call this start centers. By default, if none of them are assigned, then they are going to be set to be 0. And private list of transform. So centers are not going to be for the black ones, so that's why I'm using the list, and we can directly pass the ID. So 0 is going to be denoted by 0, and the rest of them are going to be you can just directly pass the ID and it will be assigned here. But the main point is they should be ordered properly. 0 should be at 0 and the 6 should be at 6. And private dictionary for integer to spawn block. And again, I could have created as a list, but maybe we would have different combination of colors. It's not necessary that we are going to use 0, 1, 2, and 3. So that's why I'm using a dictionary. So let's create a spawn blocks, and finally private vector 3 for the starting position. And the starting position is for the spawn block. And let's see what we need to do at the start. So first we need to spawn the block, and then we need to spawn the grid. So not spawn block. Let's create our first function, private void spawn, and if is new level, and it is going to be if rows not is equals to level dot rows and columns is equals to level dot columns, and we are attaching a not, so it is not, and it is going to be a new row, new level. If it is a new level, then we need to initialize it. So level dot rows is going to be equal to rows, level dot columns is going to be equal to column, level dot block rows is going to be equal to spawn rows, and level dot block columns are going to be equal to spawn columns. Level dot blocks are going to be equal to new list of block piece, and level dot data is going to be a new list of int, and we'll assign everything to be -1. So int I is equals to 0, I less than rows, and for int j is equals to 0, j less than columns, will level dot add and level dot data dot add, and we are just going to add -1. Everything is going to be black at the start, and that's what if it is going to be new. But after everything is set up, we need to initialize it. So our grid cells are going to be new cell, and we'll pass our row and the column. Why is it valid to update it? Let's pass the int I is equals to I less than rows, for int j is equals to 0, j less than columns. Grid cells of I and j is going to be equal to instantiate, and we are going to instantiate our cell prefab. Why is this prefab? And after instantiating grid cells of I and j, we are going to initialize and will pass the level dot data I multiplied by columns plus j. So and grid cells of I and j dot transform dot position is going to be new vector 3, j plus 0.5 plus 0.5 and finally 0, and that should spawn everything, and our current cell fill value is going to be -1. Everything is going to be turned to black. Now where's there the spawn grid? Okay, we'll need to also create our spawn grid. Again, it is going to be a pretty big function. Already 10 minutes, doesn't matter if it's 10 minutes more. And yeah, and we also need to create the function for attaching the button. So let's create that. Public void change cell fill value. We need to pass the integer of value, and we'll set current cell fill value is going to be equal to the value whatever it is passed. Now let's create our private void for spawning the grid, and inside our spawn grid uh, we need to initialize all the center objects and the blocks and also spawn them. So let's first get the starting position. So our starting position is going to be 0, and our starting position dot x is going to be 0.25 plus level dot columns minus level dot block columns multiplied by block spawn size and multiplied by 0.5. Similarly, we'll set the y position, which should be direct level dot block rows multiplied by block spawn size, and we'll subtract 2f, 1f, and also add 0.25. And we need to create the grid again here. So for int I is equals to 0, I less than spawn rows, and for j is equals to 0, j less than, why is this autocorrect so bad? Spawn columns will need to add to initials. So let's first get our spawn position. So let's add a vector 3, and we'll call this spawn pose, and it's going to be starting position plus, and we'll create a new vector 3, and let's pass 0 0 0. So vector 3 spawn was start position. Okay, here we need to add vector 3. I think we added the system.numerics, which we are not going to. Plus is ambiguous of type vector 2 and vector 3. How is it ambiguous? Okay, so our start pose is vector 2. We need to set it to vector 3. And now let's create vector 3. Spawn position is going to be equal to start position plus new vector 3 of 0 0 0. But inside the values we need to pass j multiplied j comma I. So x coordinate is going to be j, y coordinate is going to be I, and we need to multiply it by the block spawn size, and that should be our spawning position. And we will get our transform and spawn cell, and it is going to be instantiate our spawn background prefab, and we just need to sell the position to be equal to spawn position. We could just directly create it in one line, but I did it that way. And float max columns and camera. So we just need to set up the camera. I'll just copy it from here. So it is going to set up the camera position. There's no need to repeat it. Right, that's the same thing. And after that, we are going to set the start centers. So these are just different positions for all the blocks where the center is located, and we need to detect it. So integer to vector to int, and center objects are going to be equal to new list of transform. And also our spawn blocks are going to be equal to new dictionary from integer to spawn blocks, and our list of sprite, our sprites are going to be equal to block sprites. And after that, for each of the sprite, I is equals to 1, I less than sprites dot count. So for each of the sprite, we need to create the center and store it, and whenever we need it, we are going to recall it. So spawn blocks of I minus 1 is going to be equal to null. I is equals to 1 1 1. Okay, 0 is going to be equal to null, and the start centers of I minus 1 is going to be equal to 0, and our center objects dot add, we are going to instantiate our center prefab, and center objects of I minus 1. So this is going to be the starting one, dot get child of 0, dot get component of sprite renderer, and for that sprite is going to be equal to our sprite so far, and we'll just hide it. We don't need to show at the start, so it is just going to initialize it, so everything is going to be hidden. But after that, for each of the valid blocks, level.blocks.count, we need to set up. So let's get the ID. it should be level dot blocks of I dot id, and after that position is going to be level dot blocks of I dot center position, and center objects of our temporary id dot object dot set active is going to be true, and center objects of temporary id dot transform dot position. So its position is going to be new vector 3. We need to pass the y and the x, so post dot y plus 0.5, pos dot x plus 0.5, and finally 0. F, and spawn blocks of temporary id is going to be instantiate our block prefab, and spawn blocks of temporary id dot init, and we are going to pass our block which should be inside the level dot blocks of I, and the starting position which should be the starting position, not block rows, level dot blocks. So that should spawn it. We just need to assign the button, and finally in the next part what we'll need to do is just add all the functions. When we click, when we right click, and when we press the spacebar, it is going to be spawned, and when we are able to move. So our code is not having any problems, so let's set everything up. So let's go inside our prefab. Block doesn't have anything. Block piece, block size is going to be 0.5. We need to attach the block prefab, and we need to copy from our block. Let's copy this. And did I change it? Yeah. So we need to paste all of the sprites which are going to be our block sprites. Paste. So all of 8 of them are placed. For our cell, again we need to paste the cell sprites. Again, cell renderer is going to be its own renderer. Center, nothing. Spawn block, also nothing. Now let's go inside our level editor. So let's pass 3 3, and spawn rows are 3 6. Spawn background prefab. Level is going to be inside our level. The cell is going to be our default cell. It should have the cell script attached. The center prefab is going to be our center, and finally our block prefab is going to be our spawn block, which is our block piece. Now if we hit play, everything should be fine, and index was out of range, so temporary id I is equals to 0. So there is one minor problem. So let's leave it at there. We'll see where the problem is, but what we'll do is did everything spawn correctly? So that's why I'm just changing it. And yeah, so everything did spawn correctly, but there is some issue, the spawning block. So where did the start position go? I think it added at the positive instead of the negative. So negative, yeah. So that was the only problem. So the only problem was the minus here. That's why it was getting spawned there. Let's hit play. And that is the main part we want to see. And all the initialization conditions we detect it afterwards. So that is the grid spawn. The centers and everything is not spawned, but yeah. Also, a level would not, did it change? Yeah, it did change. So why did it change? It should not have changed. We directly modified it, and we did not save it. So there is also, we're going to that issue. So we just spawned everything, and the button functions are going to be remaining to be assigned. So we first need to attach our level editor, and we need to attach the function which is going to be the change self fill value. 0 is for -1, and the rest are going to be from the 1 to 6. So 2 as 1, 3 as 2, 4 as 3, 5 as a 4, 6 as 5, and 7 as 6. So almost we have spawned it, and in the next part we are going to see how we'll edit our level, and whatever the center objects in the blocks are, we are going to show them. So let's go to the next part. So in the previous part, we spawned our grid. Now we need to add the functions to change the values for our levels, and most of them is going to be for the update. We also need to fix the bug where all of the blocks were not correctly spawned. So we'll also need to see that. So let's go inside Visual Studio, and we are temporary ID. So where is the sprite? Temporary ID, temporary ID, 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 ID. So there is not any problem there. I minus one, I minus one, I minus one, I minus one. So there is I minus one, one, two, three, four. And let's go to the update function. So let's add the update function, and first is going to be if input dot get mouse button down of 0. So whenever we click anything, we are going to update that cell's value. So it is going to be setting the correct position, and let's create our mouse pose, which should be equal to camera dot main dot screen to world point of input dot mouse position. Will convert to mouse pose 2D, which should be equal to new vector 2 of mouse pose dot x and mouse pose dot y. And finally, we are going to convert it to a vector integer, which is going to convert it to grid coordinates. So new vector to int and mathf dot floor to int, and we'll pass the mouse pose dot y, that is for the row, and similarly mathf dot floor to int of mouse pose dot x. And after that, if is not valid position, then we are going to return, and we'll pass our mouse pose grid, and we'll return else. If it is a valid position, then grid cells of mouse pose grid dot x and mouse pose grid dot y and dot init for our current cell fill value, and we also need to update the data. So it is going to mouse pose grid dot x multiplied by columns plus mouse pose grid dot y, and it should be equal to our current cell fill value. And we'll use editor utility dot set dirty, and we'll pass our levels. So now we should be able to like update all of the colors, and it should show us the colors. So let's do that, and let's create our valid position. So it is going to be private bool is valid position, and we are going to pass a vector to int of pose and return pose dot x is greater than equal to 0 and pose dot y is greater than equal to 0, and pose dot x is less than rows and pose dot y is less than columns. So if it is a valid position, then if it is not valid position, then we are going to return 0 and 0 ADS. So it should allow us to update the values, and we are not using this, so we just directly delete it. Let's go inside Unity and let's see if we can see our values changing. And as we have not saved anything, so let's click the white one, so we can change the color to white. We can also change the color to red, and we can change it to any color as we like. So if it is a valid position, then we should be able to change the colors. And we can also change the color to black, which is going to be our anti-sprite. So that's how the colors are going to be changed. Now what we need to do is set up the centers, which is assigned to our right mouse button. So let's go inside Visual Studio and so if input dot get mouse button down of 1. So what happens when we are going to click the right mouse button? So same thing, we'll get the position, we'll get the grid, and if it is not valid, then we are going to return. Similarly, if our current cell fill value is -1, then we are going to return. And after that, we'll just turn on the respective grid and save it to the current block. But our current block should exist, so it will create a problem. So for now, we are just going to save it to our dictionary, which just saves it there. Previously, everything was set to 0. So center objects. So center objects for the current cell fill value. Where is my code? So center objects for the current cell value dot set active to true. So it is going to turn on only active ones. And center objects at current cell fill value dot transform uh why is it showing like this? So mouse pose grid. So center objects at our current cell fill value dot transform dot position is going to be the new vector 3. And for the x position, we are going to pass the mouse pose grid dot y plus 0.5f. For the y position, we are going to pass the x plus 0.5f and finally 0. And after the position is set up, we need to update the start centers for our center current cell fill value to be equal to mouse pose grid. And again, it is pretty simple. What it should do is it will show us our current cells center. And let's go inside Unity and let's hit play. So now we should be able to save. So let's hit save, and the values are currently saved. And if we right click, so we have our spawn block. There is an error. Center objects of current cell fill value dot game object dot set active to true. So it is done correctly. If it is not valid position and if it is not -1, then we are going to return. Okay. So I mean that was, I think it was -1. So that why return. Let's click on the blue one. Must be non-negative and 2. So now we are getting errors. Why is it showing an error? So let's hit save. And now for the blue one, index was out of range. So center objects for the current cell fill value. Center objects dot add I is equals to 1, I less than sprites dot count. Let's use a debug.log current cell fill value debug.log center objects dot count. I think new list of transform. So let's see where the error is. I just added two debug logs and so 1 and 0. So 1 is the current self fill value and the center object is set to 0. So spawn block piece, center transform, center objects dot add instantiate of the center prefab. Yeah, there are the blocks, right? So that was the error and we'll need to change it. So we need to copy, not copy property path. So as you can see, none of the sprites were added. So that's why it was causing the error. Now we can hit play and it should be fixed. So let's click on the blue and we can click it here. We can place it anywhere. And similarly, we can do for rest of the sprites too. But here it is just going to show up when we spawn. We are going to set it center and just restart it again. So yeah, we fixed it and it was easily debuggable as we just used two debug logs for why it was not showing. So why it was not showing the current cell fill value is always going to be changed, but our center objects dot count it was 0. So why it was 0? So when we initialized it, it was dependent on our where is sprites dot count and our sprites were not initialized, which were the block sprites. So that's why it was getting an error and we fixed it. And now what we need to do is how we are going to spawn it. So spawning is again going to be pretty simple as we already spawned at the start. The only thing we need to change is setting up the values. So we need to get the block piece, which is our struct. So if input dot get key down of space keycode dot space, then we are going to spawn our current self values, whatever it is. So if our current self value is -1, then we'll just directly return. But if it is not -1, then we need to get our spawn piece and will need to create a function for that. So get block piece, so it is going to return a block piece. And let's use a for loop and level.blocks dot count, and if level dot blocks of I dot id is equals to font piece dot id, then level dot blocks dot remove at I, and we'll subtract the I because the I is going to be changed. And where is this one error? Get block piece does not exist. Yeah, we'll need to create. So that is the block piece and we are removing it from the block. And level.blocks.add, we need to add our current block, which is our spawn piece. And after adding that, if our spawn blocks at our current self fill value is not equal to null, then we need to destroy our spawn blocks of current self fill value dot game object, and spawn blocks of current self fill value is going to be equal to instantiate of our blocks prefab, and we need to initialize it. So spawn blocks of current self value dot init, and we need to pass our spawn piece and our starting position, and we need to save it. So editor utility dot set dirty, and we'll pass our level. So now we should be able to spawn, and it is going to be obviously spawned at the 0th position. And how we are going to get the block piece, we'll need to create that function. So private block piece get block piece. Where is E? C E. And what it is going to do is int, let's get the ID, which is going to print self value block piece result, and we are going to return the result, and our result is going to be a new block piece. Result dot ID is going to be ID, and result dot center position is going to be start centers of the ID, and result dot starting position is going to be equal to 0, and result dot block positions is going to be new list, and finally for int I is equals to 0, I less than rows, for int j is equals to 0, j less than columns, if our grid cells of I and j and dot cell value is equals to id, so it is similarly colored, then we'll add result dot block positions dot add, and new vector to end of I and j. So they are rows and columns, so it does not matter. Result dot send false. And finally, we are going to return the result, and we should be able to spawn a block. No errors here, and everything was perfect. So let's go inside Unity, and again, it is going to be saved. We'll also be able to detect if our block was spawned correctly. So currently, we'll need to click on the blue and void space. So as you can see, it is spawned, and when we load the level again, again it is going to be at its own position. Let's change the position, and as you can see, it is going to be spawned respect to the center, and it is going to be saved. Now the last thing we need to do is move them, cause they are always not going to be positioned at 0. So we are just going to use the WSD keys to move them around and create our own level. So moving is going to be pretty simple. We just get the block, and private void, we'll call this move block. Let's go inside Visual Studio. So private void move block, and what we are going to pass is the offset, and it is going to be in the rows and the columns. So for int I is equals to 0, I less than level dot blocks dot count, if level dot blocks of I dot id is equals to current self value, and we are going to update that. So vector to int position is going to be equal to level dot blocks of I dot starting position, then with x and the y, then we need to get the block piece as it is a struct. So level dot blocks of I, change its value, and again place it level dot blocks of I to be equal to p. So we just changed its value and added it, and we can only do that if we like directly remove it. So yeah, so it will create some problems if you don't know that. And let's create our move pose, which should be spawn blocks of our current self value dot transform dot position, and move pose dot x plus is equals to offset dot y multiplied by the block spawn size, and similarly move pose dot y offset dot x multiplied by the block spawn size. And finally we'll change its position. So current self value dot transform dot position is going to be equal to move pose. And how we are going to move it, using key codes. So if input dot get key down of a, then a is going to be left, so we are moving one column to the left, and it is going to be 0 minus 1, then it is going to be down. Similarly, if input dot get key down of d, then we are going to move up, and if input dot get key down of s, then we are going to move left. So s is for the bottom, and for the bottom we are decreasing the row, so it is going to be -1 and 0, so move block of left. And finally, if input dot get key down of w, then we are going to move to the right, because the row value is increasing and the row value is stored in the x coordinate, and it auto corrected it for us. And finally, instead of else, let's use else if, else if, and else if. And we also need to save it so it doesn't create any issues. And I think we can just directly save it here, edit our utility. Set dirty, and we need to pass the level, so wherever editor utility is there, and that should be the last part. And if there are not any errors, then we should be able to place all of our blocks. And let's go inside Unity and let's see if anything did break. So for the best checking, we are going to use our 3x3 block because it didn't had any errors, so it is an empty block. We can paint it with blue. Now it did spawn, so it was at 0, but we are not able to see. If we place W, then we can move it around. So let's place it at the center. Let's place the green, we can spawn, and finally place the blue, we can spawn, and we can move it around. So everything is placed perfectly fine. There are not any problems, and I am inside Unity. So sometimes I just forget to change the windows. Maybe it may happen, it may not. So I'll record. And as you can see, the level is created perfectly fine. And what we need to do is move everything to the left, close the level, and we should be able to see the level inside our gameplay. But okay, so I think we didn't update the start position when we are doing it. Editor utility dot set dirty. Yeah, so that was the problem here. We didn't update it. So the issue was editor utility dot set dirty of level was not done, so that's why the start position was not updated. And finally, the game should be finished after editing. So we'll edit all the levels again. So as you can see, it just spawned at the 0, 0 position. Yeah, it spawned at the 0, 0, and let's add a different editor. So most of the bugs are solved. If any more arises, then we'll see how we are going to do it. So let's hit play, and let's paint with blue, then green. Let's spawn the blue, then let's paint with green, spawn the green, paint with orange, and spawn the orange. And let's position them. Yeah. And similarly, we'll also position it here. So now everything is spawned, everything should be saved. And let's go inside our scenes, and we should be able to finish the game. Again, it is not. Hmm. Start center objects. Okay, so I know why it is not. Because we didn't change the value. So where the value needs to be changed? Level, current self value. Start centers of current self value is going to be mouse pose grid. But we are not doing it when we set the start. So it should be inside the get block piece. Get block piece. Okay, as you can see, we can directly get it here. So that was the issue. So it should be start centers and starting positions. So whenever you get a block piece, it is assigned at 0. It should be assigned at 0. Center objects. Game active, start, center objects, spawn blocks in it. Blocks of I. So we are not saving it anywhere. It is always going to be saved. When we are moving, we are not saving it. I got it. So when we are moving it, blocks of I piece is equals to level dot blocks of I. Piece dot start position is going to be position. Here we are just adding the offset. We are just setting up the offset. We need to add the offset. So the bug was here, instead of previously it was equal to, we need to add it dot plus equal to. So that was causing the problem, and I think that should be fixed. So let's hit play for our generator, and we'll move everything around. Let's move our blue around. So let's move the orange around. Let's also move the green around. And now let's hit play. So it should have been moved and it should be positioned at the correct position. So instead of doing the plus equal to, I was just directly using equal to. And we should also be able to finish the game. So how the game was supposed to be finished. Let's add it here. We cannot add it here. Let's position it there. And this is going to be positioned it here. We cannot move anything, and the game is finished. And that was it for the blocks game. So if you finished the game till now, thank you guys for watching. And if you bought the course on Udemy, thank you for buying the course. And if you want to buy any other course, buy from my link. So it will help support the channel. And almost, or not almost, every time the video is going to be free, but you can support me by buying on my Udemy course link, which should be in the description below. Thank you guys for watching, and see you guys in the next one.